प्यारे बच्चों, today we will discuss next topic, conversion from state space to transfer function. This is the second part of conversion. In this part we will convert a system from state space to transfer function. Means system is represented by these two state equations. First one is the state equation, second one is the output equation. So any system can be represented by these two equations in a state space. To find out the transfer function for any given system, first we have to find out expression for transfer function. This is the expression for transfer function. We can derive this expression of transfer function from these two equations. How can we derive? So first take the Laplace transform of these two equations. Taking Laplace transform of first equation, this is the third equation. Obviously initial conditions are 0 for transfer function. So this is the expression in Laplace domain. And second equation is the output equation. And after taking Laplace transform, this equation is converted into this equation number 4. So these are two equations, third and fourth, in Laplace domain. Now from these two equations, we can find out this expression of transfer function. From this one, we can write, so transfer this term of input to the left side. This is the expression. Then we can take common of this expression. And from this is the equation number 5. And you can put this value of xs into this fourth equation. Then this fourth equation becomes like equation number 6. And in this equation number 6, this part is the transfer function, because this terms relates input. This is the input and this is the output. So this term relates input to the output. So these are vectors. So this is called the transfer function vector. If these two are single input and single output, then from this expression number 6 we can calculate transfer function. So transfer function, which is the ratio of output to input, this can be obtained by this. So this is very important expression for transfer function. We can solve numerical problems based on this transfer function. So this is the basic relation. Now from this expression we can find out transfer function corresponding to a system represented in state space. So this is the basic expression. Suppose we are taking one example here. So now problem 1. Suppose any system is represented by two equations. So first one is the 0 1 0 0 0 1 minus 1 minus 2 minus 3 plus 10 0 0. This is the input and output expression is given by 1 0 0. This is the, so these are two equations 1 and 2. So any system is represented by these two equations. You have to find out transfer function. This is the question. So now expression of transfer function is given by this. This is the basic equation. So this is the expression for transfer function. So what is A? So first of all calculate all these matrices A, B, C, D. For this given problem, this is the A. Two basic equations by comparing you can find from these two equations what is value of A? A is this one 0, 1, 0, 0, 0, 1, minus 1, minus 2, minus 3. What is B? B we can write B is this one 10, 0, 0. What is C? C is this is row matrix, and what is D? This is 0, null matrix. So first of all, to find out the transfer function, we have to calculate this term, inverse. Obviously, inverse of this is given by adjoint of this divided by determinant of this matrix. So this is the basic expression. So from these given values of A, B, C, D, by comparing given problem to standard form, we can calculate matrices, then we can find out transfer function by using basic relations. So first of all, you have to calculate inverse this term. Obviously, adjoint upon determinant. So what is adjoint? Suppose matrix of cofactors. Matrix of. So first calculate this matrix Si minus A. For given problem, A is given. We can calculate this. This is the 0, 0, 0 is 0, 0 is minus A. A is given 0, 1, 0, 0, 0, 1, minus 1, minus 2, minus 3. So this is the identity matrix is for 3 cross 3 is 1, 0, 0, 0, 1, 0, 0, 0, 1, and after multiplication by S we have this is the first part and this is the second part given matrix. So after calculation you can find out this value. X minus 0, that is S, 0 minus 1, that is minus 1, 0 minus 0, 0, 0 S, 0 minus 1, that is minus 1, 0 minus 1, that is 1, 0 minus 2, 2, S minus 3 and S plus 3. So this is the Si minus A matrix. Now you have to find out adjoint of this. So major part is first calculate adjoint of this. Suppose matrix of cofactors is given A1, A2, A3, B1, B2, B3, C1, C2, C3. Suppose this is the matrix of cofactors. This is the matrix of cofactors. Then you have to calculate. After calculating matrix of cofactors, transpose this. After transpose, the expression is like this: B1, B2, B3, C1, C2, C3. So first calculate matrix of cofactors, then transpose that matrix, you will get adjoint. So first of all we will calculate adjoint. So calculate the matrix of cofactors of this given matrix. So you can see here, this is the, once again I am writing, this is the matrix minus 1, 0. This is 1, 2, this is 3. So now calculate all these things: A1, A2, A3, B1, B2, B3, C1, C2, C3. Means cofactors. Method is very clear. Suppose first cofactor, you are calculating cofactor for this. So minus 1 to the power row plus column. Okay. So if for this element minus 1 to the power row is first, column is first, 1 plus 1, that is minus 1 to the power 2, that is 1. So for even numbers we have positive, and for odd numbers this is negative. So after calculating cofactors, next I am writing all cofactors of this directly. You can calculate and check. So this is the first one. Second cofactor is minus 1. Third one is minus s. Then b1 is s plus 3. b2 is s plus 3. b3 is minus s plus 1. And c1 is 1. c2 is s. c3 is s square. So these are cofactors. And adjoint, so we can write adjoint of this. After transposing, you can write here a matrix. This is s square plus 3s plus 2 minus 1 minus s. So all these values, s plus 3, s square plus 3s. This is minus 2s plus 1. This is 1 and s square. So this is adjoint of this si minus a. Now we have to calculate determinant. What is value of determinant? You can calculate this. I am writing directly. This is the after calculation 3s square plus 2s plus 1. So from here we can calculate this determinant, and after getting these two values, finally we have to find out transfer function for given system. So now come to the transfer function. What is the method? Basic relation is, for transfer function you have to multiply three matrices. This is the inverse matrix in 2D. Okay. So this is the inverse matrix. So you can calculate this. C So now come to, after calculating this, so you can put these values, and from here multiply this. After multiplication of this, SI minus A inverse, multiplication of these two. So what is value of C? Value of C is given. So you can calculate this. C is given 1 0 0, and here you can use this. Multiply by, so what is this? This is square plus 3s plus 2 minus 1 minus s plus 3 plus 3 plus 1 s square. So now multiply these two matrices. So this is matrix of 1 row 3 columns. So this is 1 cross 3. This is 3 cross 3. After multiplication, you will get a matrix of 1 cross 3. 1 cross 3 means 1 row 3 columns. So after multiplication, you will get, this is square plus 3s plus 2 s plus 3 1. By rule of multiplication, and we are multiplying, here means having 1 row 3 columns. So this element is obtained by, this is the element of first row first column. So first row first column after multiplication of corresponding terms, 1 into this plus 0 into this plus 0 into this, you will get this. For this element, first row second column means first row second column. So 1 into this plus 0 into this plus 0 into this, so you will get this second. And for third one, this is the first row third column, that is first row third column corresponding terms, 1 into 1 0 into s plus 0 into s. So you will get this after multiplication. Now one thing more, after multiplication you have to multiply this by another matrix. So next multiplication is, so now we can write this transfer function is given by I minus b equals b, because this is null matrix, so we are writing this term. So you can write 1 upon delta is included here. S plus 2 s plus 3 1, and value of this matrix is 10 0 0. So now you can multiply. This is the 1 row 3 column, this is the 3 row 1 column, this is the 1 cross 3, this is 3 cross 1. So 1 cross 1 meaning only single element is here. So single element is here. First row, first column means first row, first column. So this is the 10 into this. So this is the transfer function. So transfer function is given by 10 3s plus 2 divided by this determinant term, which is already calculated. So this is the expression of transfer function. So in this way, we can calculate transfer function for a system which is represented in a state space. So this is the basic expression for transfer function. By using this formula, we can obtain this transfer function. So major part of this is you have to calculate first inverse matrix, then two multiplications. First multiply by C matrix, then multiply by B matrix. So in this way, we will get the final answer. So you can note down two more problems for home assignment. You can take two problems for home assignment. So question number 1 is, this is the question is -4 minus 1.50 plus 20, this is the 2 ut, and output is given 1.5 0.625 x. Find transfer function. Question number 2. Then note another problem. X dot 010 001 -3 -2 -5 plus 0 0 10, and y is given 100. Find transfer function. So both these two problems are based on this expression. Transfer function is given by, we have to write the expression simply. Use this expression to calculate the transfer function for these. You can also note answer of these two problems. So for first one, first problem answer is, answer of first question is transfer function. After using this expression, you will get 3x plus 5 divided by plus 12 plus 4x plus 6. And for second problem, transfer function is given by 10 upon this cube 5s square plus 2s plus 3. So this is all about conversion from state space to transfer function. By using this expression of transfer function, we can convert any system represented in a state space to a transfer function. So simply you have to calculate inverse of matrix, then multiplication of matrix. So two processes are involved here in this conversion. One is first obtain inverse of matrix, then multiplication of matrix. Two multiplications are used. You will get simply transfer function for this. So this is all about conversion.